For hanging in till the very end. I'll try and make good use of your time and appreciate your interest in this topic. I'm going to try and do three things in this talk. Just introduce some of the nomenclature I use about open source and cloud as it refers to building products and services out of the cloud with open source tools. And then zero in on a case study for a solution that we've brought to market about 5 years ago with rolling our own open source and have recently transferred to more of a platform delivery architecture, and explain some of the dollars and cents and business decisions behind both the original decision and the migration decision. And I think it's kind of obvious to us all, but it's worth stating that the cloud is a total difference maker in our industry, in business in general, and in life. Just the notion of the picture you take here or your wife takes, you can show your friends on a phone because of the cloud technology. Small business like ourselves, our ability to expand into different states for the cost of someone having an internet connection and us using software as a service like Gmail and project management tools that are delivered through the cloud. And it's a real difference maker in the task of trying to build and deliver solutions to your customers. So, what does one of those things look like? You have some business idea. You want to do something. It involves geotechnology. You think it'll work. You hope it'll make money. And if you can minimize your costs, you'll make more money. But you don't want to compromise quality. No one's sort of saying, well, you take open source because it's cheaper, but cheap. No, it's a better value. And so if you're on this bus, where do I begin and what choices do I have? And one of the more complicated parts of our industry is there are lots and lots of different building blocks. And I just wanted to sort of walk through the building blocks that I see as available in 2016. First, there are commercial building blocks, many of which are deployed through the cloud now, but there's commercial software, things like ArcGIS Server, that you run and manage yourself. Equally, there's open source software that you run and manage yourself, things like PostGIS or GeoServer, MapServer, or any of those things. And then there's both platform as a service and software as a service that other people run in the cloud and that you access typically through end user applications or APIs. So some of the simple basics of the cloud: infrastructure as a service, platform as a service, software as a service, and some examples that I think that I hope bring it home a little bit. The cloud is not homogeneous. There's not like one cloud and one kind of thing that you get out of the cloud. There's really at least three things and probably many more variations on the theme. There's infrastructure as a service, as I said, platform as a service, and software as a service. So, why do you get into software as a service? I don't want to install things on my PC anymore, and I don't want to have to be responsible for reinstalling upgrades. I just want to have a good browser and I can get at what I need. I don't want to pay for software a big fee once and then pay maintenance every year. I'd rather just pay a monthly fee or an annual fee to get what I need on the device that I need. And I'd like to access all of my stuff through the internet, wherever I may be, when I'm on vacation if I choose to do that, when I'm at a conference if I need to, and on my phone or my Mac or my PC or my tablet or whatever the case may be. And again, in my private life, I use Shutterfly for photo management and making the little books after vacation and all of that kind of stuff. And in business, Salesforce is kind of the master use case. And in fact, their logo includes no software as one of the elements. And then there's platform as a service, something like CartoDB or ArcGIS Online. And again, what are you thinking about when you choose platform? I don't want to run my own servers. I don't want to have to keep them up. I don't want to have to keep current on the software that's on them. I'd like to access stuff. Maybe I'm a developer. I'd like to access stuff through APIs or consume web services that give me access to my information that's in your platform. I'd like to take advantage of cloud scale. If I'm successful, I want to be able to grow as seamlessly and cost effectively as possible. And then I'd also probably like some out-of-the-box tools that do some chunk of what I'm trying to do. You know, in the CartoDB land, there's a default viewer and visualization composer. But there's also a SQL API and a JavaScript API. And similarly in ArcGIS Online, there's default viewers and templates and a variety of other APIs. And then for infrastructure as a service, and again, both Amazon, AWS, and Google Cloud Platform, Microsoft with Azure have these kinds of offerings where you're essentially renting virtual machines out of their cloud. And so what are some of the questions you do? I want low cost and I want to pay by consumption. I don't want to have to buy the biggest server I'll ever need. I want to buy a small server first, and when it gets busy, I'll buy a bigger server. And you can make those adjustments month by month. I don't want to buy any hardware myself. I'd like to rent or lease access to the hardware. I don't want to have to deal with a data center. Even a small company like ours, we have a closet, we have an air conditioner, and we have some racks, and pizza boxes in those racks, and stuff breaks, and including the air conditioner. So I don't want to have to deal with that, or I want to minimize how much I have to deal with that. And I want the flexibility to scale. As I grow, I can get more capacity, and if I make a mistake and the server's too small, or I need more RAM, or I need more disk, I want to be able to just go to a website and get that more disk as seamlessly as possible. And the other part of scaling, and the other thing you sort of take for granted with some of the infrastructure as a service is, you know, Amazon and Google have the biggest internet pipes in the world. So if you're running stuff on premise and you get really busy, your internet pipe is getting clogged up. But if you're in someone's cloud, it's up to them to have the internet pipes, and they have the capacity on those pipes. So those are kind of the building blocks and some of the cost and architectural choices that are out there. So how do you make sense of this? Some of it is, okay, what do I want? What do I have for software options besides the platform options? And one of the complicated things about open source is there's so many different kinds of tools. So just, you know, we've seen talks this week on all these different categories. There's the server-side database, things like PostGIS. There's web map servers, things like GeoServer and MapServer, GeoWeb Cache. There's the JavaScript frameworks, OpenLayers, Leaflet, and then desktop choices, UDIG, QGIS. And it's good to see some favorites emerging, but, you know, how do you choose what you want? And there's other choices that are implied, like what do you do on the desktop versus the server versus the cloud? Is the open source equivalent to the commercial, or is it functionally equivalent for my use case to the commercial offerings? And then there's the open source versus open source. How do I choose MapServer between GeoServer? And they're all legitimate questions, and as you get into the ecosystem, some of the answers aren't so clear. So you have to go shopping, and you have to be a smart shopper. And now increasingly, there are this sort of new class of things, these software as a service and platform as a service, that are built under the hood with open source in somebody's cloud. So again, if we start with CartoDB, it's PostGIS under the hood, and they've built all this great stuff on top of PostGIS that makes it more accessible and friendly, but there's still a super great SQL API, so you can do incredible geospatial analysis with one SQL statement. Similarly, MapBox has built an engine powered by open source. They've open sourced some of their own tools to deliver OpenStreetMap and geocoding and routing and imagery across the globe, competing in many ways with Google Maps. Planet Labs delivering satellite imagery as a service, again, powering their infrastructure with open source. And then Fulcrum delivering mobile apps, mobile data collection apps as a service. Sign up for a subscription, make a form, decide if you want a photo in your form or not, and in a few hours, you're out in the field collecting. Charged by the device by month, plans for the year, whatever the case may be, and you have lots of flexibility. And I think we'll start seeing more and more of these kinds of choices. And as a result, with all of these choices, increasingly some of the decisions end up being hybrid. And I have a very lovable hybrid dog in my house. gives lots of love and encouragement to all of us. And again, hybrids are good. They're smart. They don't have bad hips and overbite, and they live longer, and all of that kinds of thing. So what do some of these hybrids look like? There's really lots and lots of ways of mixing and matching. So if we just sort of start with the commercial, a lot of people have a data management ecosystem that's built on Esri, and they've been doing it for years and years, and it works, and there's sunk costs in their software and in their training of staff. That's fine. Then there's open source tools, QGIS on the desktop, GeoServer, PostGIS, et cetera. And now there's platform as a service and software as a service. And it really is a Venn diagram. You can mix any two, or you can mix all three together. And this gives new architectural possibilities for what you can build. So taking that approach, I'll introduce our case study. It's building a public-facing geo software as a service that's offered to local government and is focused on parcel data. And what are the requirements? We need to expose public governmental data. The users are not geospatial professionals. They're not IT professionals. They're people like realtors and appraisers and citizens who want to understand how much real estate is worth, or why their tax bill is so high, or their neighbor's is too low, or whatever the case may be. And it's very meaningful to government, because in the old days, you had to go down to town hall, consume someone's time to answer your query to get this public information. It's also very useful to citizens. You don't have to go to town hall anymore, and you can do it at night after work. You can get really 24/7 access to open government data. And as a result, you have to keep it simple. And again, we're a business. We don't survive if we don't generate revenue and ultimately make money. So we want to deploy it profitably. And we try and be smart about it. We believe in Brian Timoney's mantra for public-facing websites. If you're building anything public-facing, you have exactly 4 requirements: fast, intuitive, informative, and fast. And the fast part is, again, it's a result of some of the cloud things. What do people compare their user experience to? To things like Google. If it's not as fast as Google, it just feels super slow. And and to everyone's credit, CartoDB and MapBox are delivering, and Fulcrum are delivering that kind of speed and performance. It's possible with the cloud. So where did our solution come from? We've been building web applications for government since 2004, in the very early days of Esri Stack, ArcView IMS, which predated ArcIMS. And so in the old days, we built lots of different custom websites. We used MapObjects IMS, ArcIMS, ArcGIS Server, and we still have some of these sites up. And we generally would do a custom application that talked to Esri. And then we're kind of successful, and so we had 20 or 30 of these up, and then the browser would upgrade, and the app would break. And it wasn't one app that broke, it was 20 apps that broke. So it was very expensive to maintain a sort of flotilla of custom sites. So round about 2011, we set off on what we call MapGeo, which was a repeatable solution. One code base that would be configurable to the customer data. So if the browsers changed, we had to fix one piece of code. But we had to set it up so that we could take a whole variety of data for individual customers and deliver individual sites with this one code base. And the choice we made comes from the title of this talk. We rolled our own open source in Amazon's cloud, and we'll talk more about that in a little bit. It was powered by PostGIS and GeoServer, even though 100% of the data that we got from our customers was Esri data. But for optimized publication, we made the open source choice, and it ran really well up until 2015, when we embarked on MapGeo version 2, where we really did hitch our wagon to 2 platforms that we believe in, Google Maps API and the CartoDB platform. And I'll get into the details of that. And so what drove our need? Well, let me first describe the architecture. So this is the roll your own architecture. So we get our Esri data, and we have to convert it to PostGIS. And so we had all these ETL scripts, and then we were listening to Brian Timoney, and we wanted to be fast, so we had to make all our own tiles. So we had a tile-making assembly line. And then when we were done, we would push all of the tiles into Amazon. The tiles went into buckets, and then normalized parcel data went into PostGIS. And it worked great. But it was also fairly labor-intensive. Making tiles is not fun. So around about 2015, we looked to modernize, and there were really several drivers. We had been successful with MapGeo. One, we have 75 customers in 10 states, counties, councils of government, cities, towns, the U.S. Virgin Islands. But some big things changed, like these and tablets got a lot more ubiquitous and powerful, and the Wi-Fi networks got stronger and stronger over that time. And while we were somewhat mobile with our first version, we weren't nearly mobile enough. So we wanted to have a much more responsive user interface, and we really wrote it for a tablet. Its optimal UX is in a tablet, runs great on a bigger screen, and it runs quite nicely on my Samsung S6. And then we also saw the opportunity to leverage the platform and software as a service, because baking tiles is just never-ending, time-consuming mess, and you start getting into doing work for big counties that are hundreds and hundreds of square miles, and it takes a lot of time. But it goes further. The platforms have a lot of new capability that we would have had to write as custom in our own role at your own, and we can just leverage that. And I'll talk a little more about that in a moment. So what does our new architecture look like? We still have to do some customer data preparation. Again, 100% of the data to this day comes to us as either Esri shapefiles or geodatabases. We have to push it up into CartoDB, but we don't have to normalize it in the same way we did for rolling our own. We put all of the parcel data into one schema. Here, we have an API we can talk to, so we just have to map columns into names that are familiar to us. And so if we have 75 customers that have 75 different kinds of parcel data, we can just push that data as is in there and then just map the fields into the field names the application expects. And so in CartoDB, we're doing our customer layer management and styling, and then we're doing the dynamic tiling. We don't have to bake tiles. CartoDB's platform creates tiles on demand, distributes them through a CDN, and delivers them through API calls. And then we also chose Google Maps API for a couple of reasons, because we are working across the country. We wanted a nationwide base map, and very important to this use case is imagery, and Google has tremendous 6-inch imagery wall-to-wall for the United States. And so you don't have to get imagery. We get it through Google Maps API. And also in the real estate context, things like geocoding, finding an address, and having access to Street View so you can see what the house or business looks like is very important. And those are available through the Google Maps API. And we pulled it off. I won't bother demoing it. If you're interested, that's a live link to a public site from Malden, Mass. And it really does work on a phone and provide a pretty good UX and is quite functional on larger screens. And we went through the process of migrating all of the sites, which took some time and good lesson learned. Not everyone thinks it's an upgrade. People get used to the old one, the new one. They're like, oh, where'd this thing go? I don't understand. And it kind of reminds me, like if you're on Facebook, every time Facebook changes the UI, people scream and yell for about a week, and then you forget what the old one looked like, and it all goes back to normal. But there was some of that, and it took longer to get some customers to be comfortable with flipping the switch. So what are the business drivers? Why did we do this, and how did it work? And it's never over. We will have to upgrade MapGeo again sometime in the next 2 or 3 years. I saw Lizzie Diamond's talk, and vector tiles are getting closer and closer and more ubiquitous. And at some point, I have no doubt, they will be a part of MapGeo. We have to spend more money. We have a big CartoDB account. We spend about $40,000 a year on CartoDB and a little less than $20,000 a year on the Google Maps API. But we've been successful enough. I mean, you can do the math. We have 75 customers paying at least $3,000 a year. Some of our councils of government pay significantly more than that because they'll have 20 or 30 towns in them. So if you break down the $56,000 divided by 75, it's about $750 per town, or about 7.5 hours at $100 an hour. The people who do the tile baking weren't necessarily being billed out at $100. I'm just trying to keep the math simple. But you can see it doesn't take much labor savings to pay for the cost of these platforms. And sometimes you have to bake tiles a couple of times a year every time the parcel data updates. So we were seeing enormous labor savings for fairly reasonable cost investment. And the cloud and these platforms pay and are worth it. And the other thing that's really important is we feel we have a much more competitive product right now. We are more mobile. We have a unique interaction with Street View. If you demo the site, we actually are drawing in Street View, so there's a little marker in front of the house. You can change parcel by clicking in the Street View space, which is convenient if you're in the field. And then we also are getting some real nice benefits from CartoDB. We're taking advantage of their torque map, so we can animate sales over the course of a year in the city, or we can do heat maps of property value, cluster analyses of sales, and things of that nature. And it's not just us. That's our experience. That's a use case where I actually know the numbers and can tell you everything. We did some work for a very large name brand management consulting firm. And these types of customers often don't want you to talk about the details of the project. So I've done my best to anonymize it. And the project started with the classic geo visionary champion who said, we should build a geoanalytics practice. We have customers who have geospatial problems. We should build the practice. And I need to sell it internally, and I need a prototype. And this was back in 2012. He felt the safe choice was Esri. We built a prototype system for it. It was a low six figures kind of project. It was a quite involved development effort. And it was successful, and he started getting traction, and he was able to start building his team, and he hired a new person who was going to be the program manager, who was a geospatial professional, who knew a lot about the industry and knew how to do some of the choices. And I remember the first meeting with him, and he sort of came in and he looked at our prototype and he said, gee, this looks an awful lot like CartoDB. We were like, yeah, it does. And long story short, the company took it in that direction. We were done. The customer was happy. He got to start building his team. And then sure enough, 3 years later, we're at the CartoDB Partner Conference, and our customer's there showing his version 2, which was CartoDB. So essentially, they made the same exact decision we did. They had rolled their own Esri, built a custom app, found it was going to be expensive to maintain, and that the platform would solve some of their problems. They had some additional complications, the nature of their business and their customer data. They couldn't deploy in the cloud, so they actually run CartoDB on-premise. But that's one of the options that's available. And now, the last time I saw them, their geoanalytics team has over 50 people in it. So they're doing quite well, and we're talking to them about some phase 2 work. The second, and it's not just us, and my last slide, is a project we did for, I was telling this story to Brian from Fulcrum at the bar last night, the Minnesota Department of Transportation. Back in 2011, when there wasn't so much of this stuff, we won a competitive project to build a mobile data framework. What does that mean? It means the ability to set up forms on the phone and do data collection in the field quickly, and then get the field data into business systems. And they spent a large amount of money. That's a big project for any of us, $400,000. And they had good reasons for doing it. They had a bunch of different technologies from different suppliers. They had overlapping data collection efforts from different people in different divisions of their organization. And it really was a project that was ahead of its time. We did what they wanted and what they had spec'd. We're working for a very structured DOT that almost demands a waterfall approach with the way you have to justify it and get it reviewed. 15 months later, we had a mobile data framework. And about 16 months later, I first bumped into Fulcrum, and I was like, wow, that looks like our thing, but it's a little better. and they're going to take care of it. Our project is over. Now MnDOT has a maintenance issue with, again, going into the platform, hitching your wagon to someone else. They take care of the infrastructure. They take care of browser compatibility. They take care of new phone features. And they have a business imperative to keep fresh and modern, like we did with MapGeo. And so I'm not sure what MnDOT is doing right now, but they have the opportunity to make the same kind of pivot. There are new choices that weren't available in 2011, and good business reasons to make those choices. So in conclusion, both of those models work, and and again, people like CartoDB are rolling their own stuff by necessity. People like us are more positioned to hitch our wagon to these platforms, and it's really you choose what fits your use case and your budget, and also your technical capacity. You have to have more technical capacity to keep servers up and running and install patches and all of that stuff. But these last two things, technology changes constantly, and new options arrive that are typically better, and be prepared and not afraid to explore them when you get the opportunity. So with that, I'd be happy for any questions, and I'd be remiss if I didn't. I hope you're sick of hearing it already. You'll hear it one more time at the plenary. Please come to Boston in 2017 if you like this conference. We're going to have another great FOSS4G. This time the international version with hopefully 20 to 30% international attendance. So any questions? Yeah?
I'm wondering what drove the transition from AWS to Google Cloud.
It's a good question. We still have a lot of stuff in Amazon. We are also a Google business partner, so technically we sold ourselves the Google Maps API, and so as part of the exploring fully the Google platform, we chose Google, and have had very good luck with it. The competition with between Google and Amazon is very good for all of us. It's the real battle of the titans. Price is coming down. They're both in a race to get the best Docker implementation, et cetera, et cetera. So we will keep a foot in both of those clouds, and have had good luck with it. But they're functionally equivalent and very close in cost. Yeah. Yes, we have a couple of positions posted right now. Most of our open positions are on sales.
And who are you looking at? Sales? You're looking for not coders or?
We don't have currently any coding openings. It's one of the things we're doing differently. Historically, we've been very governmental focused and very services focused. And our partnership with Google has helped us get into more commercial accounts, and also building the software as a service have given us a different kind of subscription revenue than pure billable hours. But one of the things when you have products and solutions, you have to sell them, and the way you sell to government through RFPs and networking is different than trying to create awareness and strut your stuff.
Just another real quick question. Can you comment on Google's geospatial direction? I mean, they're pulling the rug out from some customers, and what are they doing?
I understand the question. I think they're doing the exactly right thing. Google is a giant company, and their notion of making money is different than anyone else's. It's like if it's not a $1 billion business, they're not interested in it. And what they looked at is what do they do best? And what they do best is Google Maps. And Google Maps is an API, but it's really content. What you're buying is all those addresses around the world, all that routing, all that live traffic, all that good base map information, all that imagery. And that's really what you're buying from them. And they create that for the consumers, for the free use people. And then if you want to make money on top of it, like we're charging people to access Street View through our thing, then you're obliged to pay them. Doing things like Google Maps Engine, they would admit was a mistake. They thought it was a $1 billion business. It wasn't. And it was more difficult engineering than they anticipated. So it was costing them more to get it to where it needed to be to even come close to $1 billion. And in the meantime, CartoDB and some others have arrived, and they do exactly what Google Maps Engine does. And so that's our hybrid. We're using Google Maps as global base map, and we're using CartoDB in the way we would have used GME if that's what we had chosen to do. The stuff on Google Earth, I don't understand quite as well, but it's really good to see Cesium so live and healthy. I think they set the bar. And there are many people who have, there are at least 2 or 3 options for good live globes out there, and the KML standard will continue to live, and you can still get Google Earth. They're just not going to put any more resources into it. Anything else? Thanks again for sticking to the end, and safe travels home.